All right, let's get some extra practice with some practice problems. Again, please try each of these problems before watching that part of the video, okay? In this first one, based on this graph, estimate to one decimal place. Make sure you're reading the instructions. The average rate of change from x equals 1 to x equals 3. Don't just try to do this in your head. Write it down on your paper. Average rate of change from 1 up to 3. So we know the average rate of change is going to be the function value at the second minus the function value at the first, divided by the second minus the first. What is the function value at 3? What's the function value at 1? I don't know. We have to find out. When our input is 3, our output actually is also about 3. When our input is 1, the output, 4.7? I don't know. Say it's approximately 4.7. We'll use the squiggly bars. Now we just replace it. Replace the f of 3 with a 3. Replace the f of 1 with a 4.7. 3 minus 1 is 2. You get negative 1.7 on the top divided by 2. And we divide this by 2, and we're going to get negative 0.85. And once it averaged, rounded to one decimal place, we'll say about negative 0.9. Lots of approximations. Let's see if the computer likes that. Negative 0.9. We type it in here. Thank goodness. I was worried. The answer it was looking for was that. Not estimated to one decimal place. But the actual logic in the software probably has this as the exact answer. And the tolerance is that as long as you're within one decimal place of this, you're probably good. If it put this, it should, I would imagine it also takes this. Yeah. Okay. All right, let's do number 5 next. The total cost in dollars to produce Q items is given by this cost function, C of Q. We're going to answer some questions about that. So find the total cost of producing 500 items. Well, the cost, 500 items, is just going to be what happens when we plug 500 items into this cost function. That's going to be 22,000 plus 1510 times Q. And we're curious for 500 items, it's going to be $29,550. And again, make sure you have a dollar sign here. Online, it puts the dollar sign for you, but make sure that you have it written down somewhere. Find the marginal cost here. That's another way of saying, well, this is how much we're spending for 500 items. How much would that 501st item cost? Not the total cost of 501 items, just the cost of that last item. Okay. Again, that marginal cost really is just going to be the total cost of 501 minus the cost of 500. The denominator is always 1 here. Right? Technically, we could write 501 minus 500 as the denominator here, but it's just going to be a 1, so we can make things a little easier for ourselves. Cost of 500 items is $29,550. We already answered that. We just have to find the cost of 501 items. Cost of 501 items is going to be the same formula, just with 501, 29,565.1. $29,565.1. Then we take the difference and we get, gosh, my brain's not working. That's just 15.1, $15.10. And it's really kind of tedious to do this, to do a big sum for the cost of 501, big sum for the cost of 500. Well, in business calculus, you'll talk about a shortcut for this. I love shortcuts. So 1510 should be the right answer. Let's see if I can do my mental math correctly. May or may not. Great, we got it. Let's do another one of these. I thought I wanted to do another fun one. Oh, I did. Great, number 10. Another fun one. I was looking at the notes and I looked at the wrong notes. It said number 7. The right notes say number 10. That is the one I wanted to do. All right, let's find another one of these average rates of change things. So f of x is 1 over x plus 2. We're going to go down algebra memory lane here. And we want to find the average rate of change from 10 to 10 plus h. You'll definitely need your own paper for this. It's going to be very similar to that long, messy one we did from the notes. Again, not the top priority in this section. In fact, I would say this is the lowest priority of this section, so worry about every other problem first before worrying about this one. So our average rate of change, we'll use that same formula. It'll be the function value at 10 plus h minus the function value at 10 divided by 10 plus h minus 10, the second input minus the first input. Now the denominator is really easy. Plus 10 minus 10, the denominator is only h. The numerator is more fun. Let's go off to the side. Say, what is the function when we evaluate it at 10 plus h? Well, that says look at our rule and replace all the x's with 10 plus h. So 1 over 10 plus h plus 2. Well, actually, the simplification here on this part is a lot easier than the one from the lecture video. There'll be more fun simplification at a later date. So we're going to get 10 plus 2 is 12. It's just 1 over 12 plus h. And similarly, we are curious about the function value at 10. Well, again, just look at this rule. Replace all the x's with 10s. It's going to be 1/12. All right, not looking as bad so far. Let's see what happens. F of 10 plus h is 1 over 12 plus h minus f of 10, which is 1 over 12. So here's the annoying part, is that we can't add these or subtract these yet. They don't have the same denominator. And you can't do this. This is wrong. You can't add something to the top and the bottom of a fraction. You can add something to the left and the right of an equal sign, but top and bottom of a fraction doesn't make sense, right? 2/3 is not the same thing as 3/4. We actually can't do that, even though it'd be nice. So even though these fractions look similar, they're actually not similar at all. We have to multiply by something to get the common denominator. Just like if we wanted to add 2/3 and 3/4, what would we do? Multiply this by 3 over 3, because it's missing a 3. We'd multiply this by 4 over 4, because the denominator is missing a 4. Well, we do the same thing here. This guy is missing a 12 plus h, so we're multiplying by 12 plus h. The one on the left is missing the 12 factor. We're multiplying by 12. And when that gives us is 12 over 12 times 12 plus h. We can leave it factored. Minus 12 plus h divided by 12 times 12 plus h. And now they have the exact same denominator. So now we can subtract their numerators. This is good. We're making good progress. I'm going to clean things up, by the way. Everything is getting divided by h. So notice I can do this. Everything is being divided by h. This just makes it a little nicer to write. Now that these fractions have the same denominator, we can subtract their numerators. 12 minus the whole numerator, 12 plus h. Again, we are subtracting the whole thing. We do need these parentheses. 12 times 12 plus h is what we've got down here. This is still getting divided by h. Remember, dividing by h is the same as multiplying by 1 over h. And now the top is not too bad. We can distribute that negative to get 12 minus 12, and then minus an h. Denominator is 12 times 12 plus h. We're still multiplying by 1 over h. Now things are getting pretty close to good. We have a plus 12 and a minus 12. That cancels. So we're just left with a minus h on the top. And the bottom is 12 times 12 plus h times 1 over h. Now everything's factored. And now we can cancel these h's too. And all that's left over is a negative 1 over 12 times 12 plus h. And that's as simplified as it can get. We could distribute the bottom, but it's usually better to keep it in factored form. Let's see if it likes our answer. Negative 1 divided by 12 times 12 plus h. It doesn't matter whether the negative is on the top or in front of the fraction, so we don't have to fix that. We got it right. So in their answer, you can see that in their answer, they actually did distribute it out. I think it's a little bit better in this form, but you can see that both forms are acceptable. Okay. Hope this helps with these problems. Have a good one. Bring your questions to me and have a good rest of your day or night. Maybe it's 2 in the morning. I don't know. Oh, this is the last video of the section, so I think it's mandatory. We say goodbye to October. She has turned around. So she's moved a little bit. Bye-bye.